In this lesson, we are going to take a look at the thin film section of the standard surface shader. Thin film reproduces the effect of thin film interference on a surface, and the most obvious example would be to create a soap bubble material using the thin film properties. This effect occurs on very thin transparent surfaces whose thickness is approximately that of the wavelength of visible light, which is around 500 nanometer. Obviously, if you are interested in the physical aspect of this shader and this effect and how it works in real life, you can check out related articles on web. But for now, I'm going to jump right in and start working and create some realistic looking bubbles and whatnot. If I run the IPR, in the scene we have an Arnold sky that provides the HDR lighting and a simple sphere that's going to work as our soap bubble. You can see it has an Arnold parameter tag with opaque disabled. Also, it has a Kant-Clark subdivision with iteration set to 3 because we have some displacements mapping going on in the shader applied to the sphere. Now in the material manager, you can see we have this shader network that I've named it thin film, and this is already applied to the sphere. And if I open it up, you can see we only have some basic displacements mapping set up just to make the sphere look a bit more organic. Obviously for a soap bubble, you might not want displacement mapping, but I think it's a bit nicer looking for the render in this scene. So we're using a noise texture as a displacement map to create this organic fill. We have a normal displacement node with scale set to 0.1 and a simple procedural node with scale set to 2 as the displacement map, and this gives us this organic look on the sphere that you see in the IPR. We take an in-depth look at displacement mapping later on in this section. Now let's add a standard surface shader and connect it to the Arnold Beauty port. First of all, let's zero out the base weight so we can see the effect a bit better. In the thin film section, we need to increase the thickness to something more than 0. Let's try 250 nanometer. Also, to see the effect, we need to set the IR value in the specular section to 1, and now as you can see, we get this beautiful thin film look. Now let's take a look at the thin film parameters. We have thickness min, and this is the minimum thickness of the thin film in nanometers. Basically, the coloring of the shader and the effect depends on how thick the thin film is. So let's try 50. As you can see, we have a kind of monochromatic look. Let's go to 100, still not much of a change. Let's try maybe 150, and now we start to introduce some colors. Let's try 200, 250. So as you can see, based on the particular look that you're after, you can use different nanometer values here, different thickness values. Let's try maybe 300, 350, even maybe 500, 600, 700. Now in this case, let's use 250 nanometers. The thickness value affects the specular transmission and code components. Normally this would be something like a noise map. You can connect a noise map basically to give some variation to the interference effect. Let me show you how you can do that. Let's add a noise map to the work area, and let's connect the noise to the Arnold Beauty so you can see it in the IPR. Let's increase the scale on all dimensions to 2. Now we can connect this map to the thickness value, and based on the grayscale value of the noise map, we are gonna get different thickness values. But the problem is the noise node outputs values from 0 to 1. But as you saw, we need values like 250, 400, or 600 for the thickness parameter. So we need to adjust the output range of the noise node from 0 to 1 to, let's say, 250 and 500. So let's add a range node to do that and connect the output of the noise to the input of the range. So the inputs min and max are 0 to 1 from our noise node. We want to adjust that range to, let's say, 250 and 500 nanometers. So let's type in those values in the output min and max. Now connect the output of the range node to thin film thickness value. And now let's use the standard surface shader as the root shader. Now we have created this beautiful thin film variation, and we can use different min and max thickness values in our range node. Let's say instead of 250 and 500, try 300 for min and 700 for max, and now we get a combination of 300 to 700 nanometer look. Or I can adjust my noise node and get different looks. For now, let's disconnect the range node and set the thickness to 250. Then we have this IOR parameter, which obviously is the refractive index of the medium surrounding the material. And for something like soap bubble, for example, it would be 1.35, 1.4, something like that. Now let's finalize our soap bubble shader. We still haven't added any transparency. If the shader we are trying to apply the thin film effect to didn't have any transparency, like mother of pearl, for example, we didn't need to change anything in the transmission section to make the material transparent. Only the specular, the thin film, and the coating section would have been enough. But in the case of soap bubble, obviously we do need transparency. So in the transmission section, let's increase transmission weight to 1. Also make sure the specular roughness is set to 0. Increase the coat weight to 1 and 0 out its roughness as well. Now in the thin film section, increase the thickness to 500. And for the soap bubble, as I mentioned, we can use an IR from 1.33 to 1.4. In this case, let's try 1.4. And here is our beautiful soap bubble shader. As I mentioned, probably we don't need any displacement mapping for our soap bubble. Sphere would be more appropriate, but you can simply disconnect the displacement map in the shader if you want to see a look without any displacement mapping. So in this lesson, we learned about the thin film section of the Arnold standard surface shader. See you in the next lesson.